Hello to all of you. This is Dr. Dhaval Maheta, and today we will understand how to do cross validation in neural network algorithm using Rapidminer. In cross validation, basically we will divide the data set into training and testing data set. This training data enters into the cross validation where the parameters are fed in. This cross validation picks up the best parameters from it, and these parameters are again loaded on the model. The model is retrained. After this, the final model which is there, it is evaluated with the help of test data. Now, how cross-validation is being done, let us try to understand. If we consider this to be the entire data, then we divide the data into some proportion. So this is a training data and this is a testing data. Normally, 5 folds or 10 folds are done on this data and the splitting is being done. So in the first split, this becomes a testing data set and this is a training data set. In second split, this becomes a test data and others become the training data. By running this number of times, we will find out the best parameters. And with the help of these best parameters, the final model is being made, which is evaluated with the help of test data. What is the advantage of cross validation? Once the model is ready, you have trained the new model. You can use the same optimization validation cycle to generate your model. And if the training data changes, then you will improve the algorithm by just running it once. The second advantage is you can train your model and upload on the server. You can also control where to store the model. Now, how we can do this in Rapidminer? Let's see. First of all, we will load the dataset part1 and connect with the result node. Press the play button. So here, the attributes which are of importance are age, gender, chest pain type, resting blood pressure, cholesterol, fasting blood sugar, resting ECG, max HR, exercise, old peak, ST slope, and the heart disease. Basically, our problem is a classification problem. So we want to use these attributes to classify the heart disease. Now I will go in the operator window and I'll activate the select attribute operator. It is possible that your original data set may consist of many attributes, but you want to only consider some of them for making the model. So I'll drop the select attributes operator here. I'll go here and subset it, select attributes, and I'll select only those attributes from which I want to make the model. Age, cholesterol, fasting blood sugar, heart disease, old peak, resting blood pressure. I'll transfer it here, apply. Now I'll activate the operator which is known as set the role operator. I'll drag it and drop it here. Neural network falls in the supervised learning technique where you have to specify the target variable or the dependent variable. So here attribute value, attribute name is a heart disease, which we have seen earlier, yes and no, and make it sure that the target role is label. Then only the algorithm will work. Now I'll activate the cross validation window. This I can do from here. I'll activate the cross validation operator from here. I'll simply drag it and drop it here. Now any operator, if it is having two layers, it means that it is having a main process and sub process, also known as a parent process or a child process. When you will double click on this, the screen will get divided into the training dataset and testing dataset. Now here, activate the neural net from here. Neural net algorithm. Drop it, connect the training with the training, model with the model, an example with true. Now activate the apply model from here. Drag it and drop it. Connect model with model, testing with unlabeled, and activate the performance operator from here. The performance operator, there are many types of performance operator. one related to regression, binomial, or classification. At present, we are having a classification problem. So we will pick up the classification performance. Label is connected with the label. Performance is connected with the performance. Example is connected with the test. Once these splines are connected, press the up arrow and you will come in the main window. Now connect model with the result, example with the result, test with the result, and the performance with the result. Press the play button. So you can see that the number of cases have increased because possibly we had folded the data set 10 times and therefore the number of samples have increased. Now here, in this case, the actual data set says that the person was not having the heart disease and the algorithm also predicted that the person is not having the heart disease. So 303 cases were correctly classified. Here, a person was having a heart disease and the algorithm also correctly classified that yes, the person is having the heart disease. So 397 cases were correctly classified. So this and this are correctly classified cases. But this is a misclassification. 111 and 107. Why? Let us understand. The person was having the heart disease, but the algorithm predicted that that person is not having a heart disease. Here, a person was not having the heart disease, but it predicted that a person is having a heart disease. Now you can go in example set, cross validation, where you can go case by case where the prediction was right or wrong. So here in first case, the heart disease was there and the algorithm predicted no, that was a misclassification. This is a correct classification. Here you will get the confidence level also. So basically you will have to see performance factor, improved neural net. You can see from here how many layers are there, description is given. Most of the time in case of neural network, we report the performance factor only. Now I can go in result history and I can see in the processes. Where it gives me the accuracy also. I'll remove all other outputs so that I can compare. Just a minute. So this is the output which is having only one hidden layer. Now let us try to increase the hidden layer and let us see what is it affecting the accuracy or not. So again, I'll go in design window. I'll double click on cross validation. I'll click on neural net and here I will activate the hidden layer. So I'll specify hidden layer. I'll make it 2 hidden layers. So hidden layer size is 5. First, second hidden layer. I'll make it 10. Apply. I'll come on the main process again and I'll run the analysis. First of all, let us see the improved neural net. I think for you, the things are very clear. See, 2 layers have increased, 10, right? Now, increasing the layers, does it increase the accuracy or not? Let us see. We'll go in the performance, 75.27. Now, let us go in result history and try to compare the results of both of them. With one layer, we were having 76% accuracy. By increasing the layers, our accuracy has gone down by 75%. 1% the accuracy has decreased. And therefore, adding the more hidden layers has got a detrimental effect on accuracy. And therefore, you should not add more layers in this data set. So this is a way you can run cross validation in neural network. For more videos on Rapidminer, kindly subscribe to my channel. Please refer my playlist in which I have already uploaded many videos of Rapidminer. You can press the like button. Thank you.